Find and classify the critical points of x squared plus y squared minus 9 quantity squared. I use 9 instead of 1, just change up a little bit. So we take the partials, we get fx equal to 2 times x squared plus y squared minus 9 times 2x equal to 0, which leads to either x equaling 0 or x squared plus y squared equaling 9, meaning you're on the circle of radius 3. In a similar way, fy equals 2 times x squared plus y squared minus 9 times 2y equals 0, which means you either get y equal to 0 or x squared plus y squared minus 9 equal to 0. So again, on the circle radius 3. So you can either have this and this, or this and this, and this and this and this and this. But this and this is just one of the points on the circle, where x is 0 and y is plus or minus 3. So we end up getting an infinite number of critical points. We get the point 0, 0, which is going to end up being a max. And we get all the points on the circle of radius 3 centered at the origin, which are all going to end up being minima, which is interesting. The second partials are a little bit messy. So here's our fx and fy again. fxx, I use the product rule, and I actually want to leave this as is. I don't want to multiply that with cy. So using the product rule, I get the derivative of this is 4 times this, plus 4x times the derivative of this with respect to x is just 2x. And I'll point out that when you plug in a point on the circle, well, if you're on a circle, then x squared plus y squared equals 9. So this part's going to be 0. And then this part, we'll see what happens at the end. In a similar way, fyy is going to be 4 times this stuff plus 4y times the derivative of this, which is 2y. So then, and fxy is going to be, let's see, so taking the derivative of this with respect to y, it's going to be 4x times the derivative of that, which is 2y. So you get 8xy. All right, so then your capital D, Hessian, or determinant of the Hessian, this. Looking at 0, 0, if we plug in 0, 0, we get, so plugging in fxx, we get 4 times 0 plus 0 minus 9, 4 times negative 9 for fxx. Same thing for fyy, 4 times 0 plus 0 minus 9 plus 4 times 0 times 0 is going to be 4 times negative 9, which is 4 times negative 9. And then plugging in for fxy, we get 4 times 0 times 2 times 0, which is right there. Same with 36 times 36, which is positive. So we know we have a max or a min. And we see that fxx or fyy was negative 36, which means it's concave up, so we have a minimum. Sorry, concave down, so we have a maximum. Apologies. And then for all the other points, so we have to think about, if we're on the circle, then it's true that x squared plus y squared equals 9. So when I plug into fyy, this part's just going to go away. So if I plug into fyy, I'm going to be left with 8x squared, which I'm not going to worry about because, well, you'll see. So I get 0 plus 8x squared, and here I get 0 plus 8y squared minus 8xy squared. And then before plugging in like a point like 0, 3, or 1 comma, I don't know, square root of 8, right? Those would be points on the circle, or 2 comma square root of 5. If you simplify this, this becomes, let's see what do I got here. 8x squared times 8y squared minus 8xy squared, but those are the same. That's 8 times 8 times x squared times y squared. That's 8 times 8 times x squared times y squared. So you get 0, which means it's inconclusive. So then we have to just think about the graph. Well, if we look back at the original function, x squared plus y squared minus 9 squared is always greater than or equal to 0. So when it's equal to 0, which is when the inside is equal to 0, which is on the circle of radius 3, that's when we're going to have a minimum, because that's the smallest value this function can have. Any other values for x and y, like x being 1 and y being 2, right? If x is 1 and y is 2, then you get 1 plus 4 minus 9, that's negative 4. Negative 4 squared is 16, and that's bigger than 0. So when you plug in values on the circle, that's when you get the minimums. So hopefully that helps clarify what's happening there.